Wind turbines are everywhere these days. You can spot them on the horizon, their blades slowly turning in the breeze. Whether you're driving through the countryside or looking out over the ocean, you might see their tall towers and spinning blades on hills, in fields, or even out at sea. These impressive structures have become a familiar sight in many parts of the world, standing as symbols of clean energy. These machines are a big part of the switch to renewable energy. They work alongside solar panels and other green technologies to help us move away from fossil fuels. They use the natural movement of air to make electricity. When the wind blows, it pushes the blades, which spin a generator to create power. Unlike burning coal or oil, wind power doesn't pollute the air or warm the planet. It's a way to make energy without filling the sky with smoke or greenhouse gases. Wind energy is clean, safe, and never runs out. As long as the wind keeps blowing, we can keep generating electricity. The wind blows because the sun heats parts of the earth differently. This uneven heating causes air to move, creating the breezes and gusts that wind turbines capture. As long as the sun shines, we'll have wind. That means wind energy is truly renewable, always available somewhere on Earth. That's why wind turbines are so important for our future. They help us build a world where energy is both sustainable and environmentally friendly. They help us fight climate change and keep our air clean. By using wind power, we can protect our planet for future generations. But how do these giant machines turn a gentle breeze into the electricity that lights up your home? It might seem mysterious at first. It's not magic, it's clever engineering. Teams of experts design, build, and maintain these turbines to make sure they work efficiently and safely. Each part of a wind turbine has a special job. From the blades that catch the wind to the generator that makes electricity, every component matters. The design is simple but brilliant. It's a perfect example of how we can use science and technology to solve big problems. This essay will reveal the secrets behind wind turbines. You'll discover how these machines work and why they're so effective. We'll explore how they work, part by part, and explain the science in a way that anyone can understand. By the end, you'll see wind turbines in a whole new light. Let's start with the basics. Wind energy is one of the fastest growing sources of electricity in the world, and it all begins with something as simple as moving air. Wind turbines work by capturing the energy in moving air, transforming it into a powerful and renewable source of electricity. When the wind blows, it pushes against the blades of the turbine, causing them to move. The shape of the blades is specially designed to catch as much wind as possible, even when the breeze is gentle. The blades spin, much like the propeller of an airplane, but in reverse. The wind moves the blades, not the other way around. This spinning motion is the first step in turning wind into usable energy. These spinning blades are connected to a central shaft, which acts as the main link between the outside wind and the machinery inside the turbine. As the blades turn, so does the shaft, transferring the wind's energy deeper into the turbine's core. This shaft goes into a box of gears called a gearbox, which increases the speed of rotation before sending it into a generator. The generator is where the real magic happens. Inside, powerful magnets and coils of wire work together to convert the spinning motion into electrical energy. It takes the turning motion and turns it into electricity, creating a steady flow of power. This electricity travels down thick cables inside the tower, making its way safely to the ground and into the power grid. From there, the electricity flows to homes, schools, and businesses, lighting up entire communities. It powers lights, computers, refrigerators, and everything else that runs on electricity, all thanks to the wind. All of this happens because of the moving air outside, harnessed by clever engineering and innovative technology. The process is simple to understand. Wind moves the blades spin a shaft, the shaft turns a generator, and the generator makes electricity. But behind this simplicity lies a world of science and design. Each step is full of smart engineering tricks, making wind power one of the cleanest and most efficient ways to generate electricity today. Wind turbine blades aren't flat like a piece of cardboard. Instead, they are carefully designed with a unique shape that allows them to interact with the wind in a very efficient way. They have a special shape called an airfoil, which is similar to an airplane wing. This design is crucial for capturing the energy in moving air and turning it into useful motion. This shape is curved on one side and flat on the other. The curved side helps speed up the airflow, while the flat side slows it down, creating a pressure difference. When wind moves over the blades, it creates a difference in air pressure. The higher pressure on one side and lower pressure on the other generates lift, just like on an airplane wing. This difference lifts the blades and makes them spin. The spinning motion is what drives the generator inside the turbine, producing electricity. The blades are also twisted along their length. This twist is a subtle but important feature that helps the blade work efficiently from base to tip. This twist isn't just for looks. It's carefully engineered so that each part of the blade meets the wind at the best possible angle. The wind moves faster at the tips of the blades than at the base. This means the tip needs a different angle to catch the wind effectively compared to the slower moving base. If the blades were flat, only part of the blade would catch the wind properly. The rest would be less effective, wasting potential energy. With a twist, the whole blade catches the wind just right, making spinning easier and more efficient. This design helps maximize the amount of energy the turbine can generate. Longer blades can catch more wind and make more electricity. Modern turbines often have blades that are as long as a football field to capture as much energy as possible. But longer blades are also heavier and need stronger towers. Building these massive structures requires careful planning and advanced engineering. Engineers work hard to find the best balance between blade length, weight, and strength. They use computer models and wind tunnel tests to perfect their designs. Blades are usually made from lightweight, strong materials like fiberglass or carbon fiber. These materials help keep the blades light enough to spin easily, but strong enough to withstand powerful winds. This helps them spin easily and last for many years, even in harsh weather. Thanks to these innovations, wind turbines can keep generating clean energy in all kinds of conditions. When the blades spin, they turn a slow-moving shaft. But the generator needs to spin much faster to make electricity efficiently. This is where the gearbox comes in. The gearbox is like the gears on a bicycle. It takes the slow turning from the blades and speeds it up. Inside the gearbox, there are many gears of different sizes. Small gears turn faster than big ones. The gearbox connects the slow shaft from the blades to a fast shaft that goes into the generator. This way, the generator spins as fast as it needs to. The generator is a key part of the system. Inside, there are coils of wire and strong magnets. When the shaft spins the coil, it moves past the magnets and creates electricity. This is a basic law of physics. Moving a wire in a magnetic field produces electricity. Without the gearbox and generator, the spinning blades would just be spinning for fun. With them, they make real, usable power for our homes and cities. Wind doesn't always blow from the same direction, you know. If a wind turbine isn't facing into the wind, it just won't work well. That's where the yaw system comes in. The yaw system actually turns the top part of the turbine, the nacelle and blades, so it always faces right into the wind. Sensors on the turbine measure wind direction, and if the wind changes, motors turn the turbine to face the new direction. This turning action is called yawing. It happens slowly and carefully, so the turbine doesn't shake or wear out its parts. The yaw system uses large gears and motors, and these parts are super strong, because turning the whole top of the turbine takes a lot of force. Without yaw, turbines would miss most of the wind's power. By always facing the wind, the turbine captures as much energy as possible. This smart system is honestly one of the reasons modern turbines are so efficient. Wind can be gentle, but it can also become dangerously strong. If a storm blows in, the turbine needs to stop spinning to avoid damage. That's why every wind turbine has a braking system. The main brake works a bit like the brakes on a car or bicycle. When the system senses dangerous conditions, like very high winds or a technical problem, the brake grabs onto the main shaft and stops it from turning. This protects the gears, generator, and blades from braking. There are also emergency brakes in case the main brake fails. Safety is a top priority for wind turbine engineers. They design the system to stop quickly but safely, so nothing is damaged. The braking system is tested often. Engineers want to make sure it works every time it's needed, because a runaway turbine can be very dangerous. Blade pitch control is another clever system inside wind turbines. The pitch is the angle of the blades as they face the wind. By changing this angle, the turbine can control how much wind it catches. When winds are strong, the blades turn slightly out of the wind. This is called feathering the blades. It helps reduce the force on the blades and keeps the turbine safe. When the wind is just right, the blades turn into the wind for maximum power. Blade pitch control also helps the turbine start spinning in light winds. By adjusting the blades, even a gentle breeze can get things moving. And if the wind gets too strong, the system can turn the blades to slow the turbine down, or even stop it. This system uses motors and computers to make tiny adjustments all the time. It keeps the turbine working smoothly and safely, no matter what the weather does. You might wonder, why don't wind turbines catch all of the wind's energy? The answer is a law of physics called the Betz limit. This law says that no turbine can capture more than about 59% of the energy in the wind. If a turbine tried to take all the energy, the air would just stop moving behind the blades. No new wind could reach the blades, and the turbine would stop working. By letting some air flow past, the turbine keeps the wind moving and spinning the blades. Most real turbines capture about 40 to 50% of the wind's energy. This is still very good. Engineers are always working to make turbines even more efficient, but the Betz limit can never be beaten. Understanding this limit helps us see why smart design matters. Every part of the turbine works together to get as close to the Betz limit as possible. Wind turbines are true marvels of engineering. They turn the invisible force of wind into the electricity we use every day. Each part, from the blades to the generator, is carefully designed to work with the others. Together, they make a clean, safe, and renewable source of power. As we move away from fossil fuels, wind energy is more important than ever. Wind turbines help fight climate change and create a healthier world. They show what we can achieve with science, teamwork, and a little imagination. There is still room for improvement. New materials, smarter computers, and better designs will make future turbines even more powerful and efficient. The story of wind energy is just beginning. Next time you see a wind turbine turning in the breeze, remember all the clever ideas inside. These machines are a symbol of hope and proof that clean energy is possible today and tomorrow.